Okay, so let's start talking about recursion and financial modelling. This is our next core module, so that means everyone in the state is doing it. So, Chapter 8, Modelling Growth and Decay Using Recursion. So, first off, sequences. Now, you would have done a lot of sequences last year, so a lot of this might be revision for most of you. So a sequence is a list of numbers written down in succession, so in order. There's an order here. Each of those numbers is called a term. Now, we're going to have a lot of words and specific terms this topic. I strongly suggest you start creating a glossary. So, as you go along, adding any word that you are unsure of to it, then look up its meaning and write it in your own words, your understanding. If you need me to clarify something, please ask. Okay, so if there's no pattern in the sequence, we call it a random sequence. But if there is a pattern, it is rule-based, and that's what we really focus a lot on, our rule-based sequences. And if we perform the same operation or calculation over and over again, this is called recursion. So recursion is doing that same thing over and over again. So it's that adding the same amount each time, taking away the same amount each time, multiplying by the same factor each time. This is recursion. Now, we have to be able to demonstrate this both by hand, tech-free, and with a calculator. So you need to be able to show through each of the sequences that you understand recursion by hand. So here I've got a little example of find the first 5 terms of a sequence with a starting value of 4 and the rule multiply by 3 and take 5. So here I've done it by hand. So 4 is our starting, initial value of the sequence. Then we've got 7, 16, 43, 124. That's the first 5 terms of the sequence. And you can see that by hand, I'm doing the calculation and showing how I've done it. Now, we can also do this on our CAS calculator. So there I've got a little screenshot of what I've done to come up with the same sequence. And we tend to use our calculator a lot with this because the numbers get big and a bit more complicated, but you need to understand what's going on. And you do need to use recursion. A lot of times people will go straight to finding a rule, but you have to be using recursion. So if you're unsure, let's go through it on the calculator how to do this. So let's do the rule that I've done here in the example. So if you type in 4 and hit enter, and then multiply by 3, take 5. You'll see when I've done the multiply by 3, the calculator has brought up ANS for answer, as in the answer that's on the previous line, times by 3, take 5. So if I hit enter, then we've got 7. Now, our CAS is pretty smart, so I don't need to type that out again. If I just hit enter, it does the same procedure again. So it takes the answer, times it by 3, takes away 5. Again. I can keep on doing that. So you need to be able to show it by hand and with your CAS calculator. But that's a good way of doing it. Okay, and some students do get confused. They're not sure how to do that recursion. They type it out every time. But this is shorter and will save you time, and that's really what you're looking for in SACs and exams. So recurrence relations. So this is where we're going to start really getting into some of the words you're going to need to understand. So recurrence relations. So this is what we use to generate a sequence. Now with a recurrence relation, we need to know a number of things. Okay, and that is the initial term, or in other words, the starting point. So, starting point, initial, so it's the start. What amount are we starting with? And I'm going to use the word amount there because we're going to use this mainly in a financial sense. So we'll learn some new words to mean this initial or starting amount. And the rule that links the successive terms. For example, that means being able to work out what that next term is from the current term in the sequence. So we have our current term, and then we need to work out the next term. And that's what our recurrence relation is. So we say our initial term, that starting point, is V0. Now, it doesn't have to be V, it can be I, N, any of these type of things. It doesn't have to be V. We tend to use V, but it can be anything, and the question will sometimes define what that is. Okay. Vn is the term in the sequence after n iterations. So, n is the number of times that we've applied that rule. So, iterations is each time we apply the rule. So, think about it with this past example. So, here, my V0 would be 4. My V1 is 7 because I've applied the rule once. So this is an iteration of that rule. Okay. So Vn plus 1 is then the next term after Vn. So this is how we think about it. We think of V0 as our starting point. Vn might be that current point we're up to. Vn plus 1 is then the next iteration, the next term. So we have our sequence that we had before, 4, 7, 10, 13, or another sequence, 4, 7, 10, 13. Starting value of 4. Our common difference, you might remember that from last year, is plus 3. It's going up by an even amount of 3 each time. So we can express this as V0 equals to 4, comma, Vn plus 1 equals Vn plus 3. Now, this is a recurrence relation. We have to write the entirety of it, both the starting point and the rule that links this term to the next term. If we don't have that, then it doesn't make any sense. If you just have this rule that links them, well, it won't make any sense. We don't know where we're starting from. We have to have both parts because this is a recurrence relation. So I'll write that out. Recurrence, which I can't spell. There we go. Recurrence relation. I'll make that uppercase. because it's a relationship. That's why we have to have both of them there. Okay, so I've stressed this again, written here, that we have a rule which links the two terms, but this is the recurrence relation. If you're asked for the recurrence relation, you have to write both parts of it. Okay, if you don't write both, it's not a recurrence relation. So we get told this every year in our, meet the examiners, that students will lose marks for not writing both parts. And every year we have students in SACS who are losing marks because they're not doing that. Now, something else I'd like to say now, and I'm going to say it repeatedly, that we are dealing with money throughout this topic. So, when dealing with money, we always round to the nearest cent, so 2 decimal places, unless we're told otherwise. Okay, so don't think about it in the physical money sense, where we've only got the 5 and 10 cent coins. You always round to the nearest cent. Okay, think about it more in terms of our electronic money, where if you go to the supermarket, you can buy a litre of milk for $1.99. If you go up to the checkout and pay for it, if you're paying for it on your phone apps or on your card, you will pay $1.99. You're not going to pay $2, you pay $1.99. It always goes to the nearest cent. Please think about it in that way. Do not round unless you are told to do so. Okay? I'm going to say it all the time, but I hope you are listening to that. Do not round unless you are told to.